Hello everyone, my name is Kashyap. I am a senior researcher in Nokia, Finland. In this video, I will be discussing about immersive media experience with MPEG OMAF, multiple viewpoints and overlays in the demo and industry track. So get started. We'll, I'll start with the introduction, followed by the first edition of Omnidirectional Media format, and then the second edition of OMAF, followed by a brief discussion on the system architecture of the demo setup, and then the demo itself, and finally with the conclusions. Immersive media technologies such as virtual reality make use of omnidirectional media and head-mounted displays to provide the immersive experience. Omnidirectional media may include, for example, 360-degree videos, which are captured inside out using omnidirectional cameras. The captured videos are then projected onto a 2D surface, namely using equirectangular projection or cube map projections. The projected videos are then delivered over network and then played back on a head-mounted display to get the immersive scene. In order to avoid multiple solutions and to ease the deployment of omnidirectional media, the Moving Pictures Expert Group, also known as MPEG, created the Omnidirectional Media Format Standard, or OMAF. OMAF defines storage and delivery formats for omnidirectional media. Media here may include videos, images, audio, and time text. The third generation partnership project has adopted OMAF as a basis for its omnidirectional video streaming. Among many things, the first edition of OMAF defines media profiles based on the high efficiency video coding standard, namely the viewport independent media profile and the viewport dependent media profile. A viewport may be defined as a small spatial region of the whole 360-degree video. The viewport independent media profile enables the delivery of omnidirectional video with uniform fidelity, whereas the viewport dependent media profile enables the delivery of high fidelity videos in the current viewport of the user in relation to the other parts of the 360-degree video. In order to achieve viewport dependent streaming, a 360-degree video may be divided into different regions, for example 2x3 in this case. The videos are then encoded in multiple qualities. The encoded videos are based on the current network bandwidth and the viewport of the user. A OMAF player may choose high quality videos from the current viewport in comparison with the other parts of the 360-degree video to get a mixed quality omnidirectional media. Each region may be encoded as a motion constrained tileset, which means they do not have any decoding dependencies on the adjacent tiles. The second edition of OMAF specifies two major features, namely the overlays and multiple viewpoints. The overlays provide additional information on top of the background omnidirectional media. Previous research has also shown that overlays enhance the immersive experience of the user. A viewpoint may be defined as an omnidirectional media captured from an omnidirectional camera. So in practice, this could mean having two omnidirectional cameras in a football stadium, giving us two viewpoints. In our demo setup, we showcase both the overlays and as well as viewpoints. For the case of overlays, there could be of multiple types, namely a spherical overlay or a 2D overlay or an overlay in the user's viewport. For example, this is the background omnidirectional video, and there could be a spherical overlay at a certain distance from the center and at a certain depth. Similarly, a 2D overlay is at a certain distance from the center, and the user who watches the scene from the center, the two green lines shows the current viewport of the user and the red line shows an overlay in the user's viewport. So as the user moves along, the overlay is always in the viewport of the user. In addition to these, the current demo setup also provides user interactivity with the overlays. which I will go once I show the demo. For the case of multiple viewpoints, a viewpoint may have a common reference coordinate system defined, which helps in defining the spatial relationship with other viewpoints in sharing the same common reference coordinate system. So the set of viewpoints sharing the same common reference coordinate system forms a viewpoint group. There could be other viewpoints outside of this group having its own common reference coordinate system. So in this current demo, we have 3 viewpoints. A user may start with, for example, viewpoint 1, look around. A viewpoint may also have its own overlays and then chooses to switch to a new viewpoint, in this case viewpoint 3, and then again look around and then switch to a third viewpoint, which is viewpoint 2 here. With respect to the system architecture, as discussed before, the current system uses viewport dependent streaming based on HEVC encoding. So each region of the 360-degree video are encoded as a motion constraint tileset and are then packaged using the ISO based media file format and segmented and delivered using the dynamic adaptive streaming over HTTP or MPEG- format. So the demo has 2 main components, namely the OMAF creator, which helps in the creation of content, and the OMAF player, which helps in the playback of the content. Based on the current viewport of the user and the current network conditions, the adaptive bitrate logic requests tiles or regions of the current viewport in higher fidelity as compared to the other parts of the 360-degree video. So as the user moves along, it may request different regions in higher fidelity as compared to the other regions. So the demo is compliant with the second edition of OMAF, and it, as discussed, uses HEVC based viewport dependent media profile. The videos are encoded using HEVC main 10 profile, and the encoded videos are encapsulated using ISO based media file format. The setup also uses the extractor track facility of the ISO based media file format, which is a rich tool for scaling to multiple devices. As far as the hardware is concerned, it uses the Oculus Quest and Windows 10 for playback and rendering. So we will go into the demo now. As seen here, there are 3 viewpoints, and I have chosen the viewpoint which is in the center. As mentioned before, the viewpoint switching is enabled by overlays. So I have been moving in the first viewpoint now. So as I turn left, you can see there is a viewpoint which pops up. So I can choose to switch to this new viewpoint, and there is a second viewpoint which is shown here. So I'm just trying to look around, and then I will switch to the viewpoint, to the first viewpoint. This is the first viewpoint, and I have chosen to switch here. So this new second viewpoint has multiple overlays. This is a 2D overlay. There is an overlay here, and these are viewpoint overlays. There is a Nokia logo here, which is an overlay in the user's viewport. So as I move along, this logo is in the viewport of the user. As mentioned before, this demo also has user interactivity. So one may choose to enable or disable an overlay. So I have now choose to enable one of the overlays. So this opens up a 2D canvas with a new overlay, and the overlay starts to play back. And then I have disabled it, and this is a second overlay which I have enabled and then played back. Okay, so now I will switch to a new viewpoint. which is popped up here. Yeah. So this is a third viewpoint with its own set of overlays, and again user interactions can be done with these overlays. Okay, so as you have seen, this demo has two new features, namely the overlays and the multiple viewpoints, along with the first edition of OMAF feature, which is the viewport dependent streaming profile. These set of tools provide the content creator with a rich set of tools to provide a richer user experience. And as a next step, we would like to improve the efficiency of the omnidirectional video streaming and also optimize the viewpoint switching capability. If you have any further questions, kindly contact us on the forums as well as on the email. Thank you very much.